I plotted those 2 points. It then talks about the vector A, B. And so if I list A first, it means that A is the initial point of my vector, and B is called the terminal point of the vector. And so notice that it might be a little hard to see the arrow, but we have an arrow drawn from point A, which is the blue point, to point B, which is the green point, and there is a little arrow there, okay? So I've drawn the vector AB. Your question says state 2 examples of vectors that are equivalent to AB. Vectors are equivalent if they have the same length and point in the same direction. So in terms of picturing the vectors really as physical things, you could pick one up and set it right on top of the other, and they match up, okay? Without without tilting it at all, because you have to keep the direction the same. But vectors are equivalent if they point in the same direction and have the same length. So how I actually drew that vector is, well, first I opened the vector part of the program, and then do you see where it says initial point? I put in point A. Point A was -3, 8, 10. And then up at the top is the vector. And right now it has numbers 7, -9, 5. So let me talk about where I came up with the 7, -9, 5. Okay, point A was -3, 8, 10, and point B was 4, -1, 15. If I'm at -3 and I end up at 4, I had to go up, right? I mean, I went up in value. How many spaces did I go up in value? 7, okay? If I'm at 8 and I go to -1, I had to have gone down in value. How many spaces did I go down in value? 9. But down in value, so -9. If I'm at 10 and I go to 15, how much did I go up in value? 5. Okay, so the difference in my x coordinates is 7. The difference in my y coordinates is -9. The difference in my z coordinates was +5. So 4 minus -3, -1 minus 8, 15 minus 10. So to correctly get the direction, you have to take the terminal point coordinates and subtract the initial point coordinates. If you don't go in that direction, you're not going to get the direction of the vector correct. Okay, so I had to do 4 minus -3 to get +7. I had to do -1 minus 8 to get -9. I had to do 15 minus 10 to get 5. But you guys, quite honestly, when I find my vectors, I'm just fairly visual, and so I do what I talked through first. Like I personally picture starting at A, and I picture going to this point, and in my head, I'm thinking, well, if I was at -3 and I went to 4, I had to go up by 7. If I was at 8 and I end up down at -1, I had to go down by 9. If I was at 10 and I went up to 15, I had to go up by 5. So I mean, that's how I find my vectors. But if you're a more mechanical, follow the definition rule type of thinker, and we're all different thinkers, then mechanically you have to start with the terminal point and subtract the initial point to get the direction correct. Okay, so some equivalent vectors would be starting at the origin, for example, so I'm leaving the vector as it is, but I'm starting at the origin. And let's make it a different color. Let's select from palette. We'll make it red. It's kind of a magenta red. Alright, so these two vectors are equivalent. They both have the same length and they're pointing in the same direction. If I leave the vector the same, but I now start at, let's see, -5, +5, 0. Okay, let's make it a different color. We'll make it something that'll show up though. We'll make it that color blue. Alright, so there's two vectors that are equivalent to that one. How would you express that as an answer on paper? And I mean, I've expressed it in graphing form, but if you were answering our question on paper, you could say, you could just list the 7, -9, 5, and when you list a vector like that, you're assuming the initial point is the origin. Okay, if you have to tell somebody what the initial point is. So if you don't tell somebody, you have to assume it's the origin. Okay, so that would be an answer. The other example that I gave, point C, -5, 5, 0, and then point D would be the vector CD. Okay, you have to list all of that. You have to, if your initial point is not the origin, you have to tell somebody what your initial point is. So you either have to draw a picture and show somebody, or you have to tell them. So the second one I made up, okay, the second one I made up, my initial point was -5, 5, 0. My vector is still 7, -9, 5. So if I start at -5 and I move 7, I had to have landed at 2. If I start at 5 and I go down 9, I had to have landed at -4. If I start at 0 and I move up 5, I'll have to land at 5. So to go from -5 to 2, I go up 7. To go from 5 to -4, I go down 9. To go from 0 to 5, I go up 5. So the vector CD is equivalent to the initial vector that we have. All right, and you know, we could make up infinitely many more. They just have to point in this direction. And they have to have the, you have to move those same spaces from X and Y and Z in order for it to also have the same length. Any questions about that? No? Yes, Warren?